What's up, guys? Every single year, this problem always seems to get students mixed up. And I think part of the reason is students just kind of forget the midpoint formula, or they just don't really understand what they're trying to achieve. So again, what we have here is we have y. Now, y, it represents the midpoint. And then for x represents one endpoint. And I think maybe why this is confusing, because you can see here, it's just a line drawn, right? So you might not know that y represents the midpoint, but it's in the middle. It's in the middle between another point, which we're going to call z. Now, it's important to remember that the midpoint is exactly in the middle between x and z. So I'm not going to be exactly perfect here, but I'm going to try to do my best here to kind of represent. You can see that, yeah, it kind of looks like in the middle, right? It's pretty close. Now, what we want to be able to do in this problem is we want to be able to find these x and these y coordinates. So how do we go about and do that? Because if you remember, when we're trying to find the midpoint, right, it's rather simple. You're just finding the middle of the x coordinates and the middle of the y coordinates. And the way that you do that is you add the two coordinates together, divide by 2. And I think if you do enough problems with that, it becomes pretty natural. However, the formal definition sometimes gets a little confusing. Let's go ahead and write it out for the x and the y coordinates. Okay, so you can see in this case, we have the midpoint, which is going to be my xm, y1, and that's basically going to be the sum of my x coordinates 4.1 and my x coordinate 4.2, all divided by 2. And I'm going to do the exact same thing for y1 plus y2. Now you might say, well, what is my x1, x2, my xm, and ym? So remember, my midpoint here is going to be my xm, right? And my ym. Those are going to be what we call the midpoints. And you don't need to use m. I like to use m because it just reminds me to use the midpoint, or that it represents the midpoint. But if you want to use 3 or any other number, you do you. Now in this case, again, the same kind of thing works with 0.1 and 0.2. Which one is going to be 0.1, which one is 0.2? Do you even need to use the subscripts? And technically, no. It's important to differentiate between the two coordinate points, because here we have coordinate points, right? An x and a y. And here we have another coordinate point, which we're trying to find. These are our answers, right? Which is an x and a y. So I want to make sure that I understand which one I'm actually solving for. So I'm just going to call this x1 and x2, and I'll call this one x2 and y2. So the important thing now, looking at this formula, we know what x1 is, we know what xm is, we know what 2 is, right? 2 is a number, but we don't know what x2 is. So what we're going to do is just simply plug these values into this equation and then solve for x2. Okay, so now you can see that I basically just replaced my -1 with xm. I replaced an x1 with a -4. Now we need to solve for x2. And again, this is where a lot of students will just kind of get confused here on how to be able to do this. And again, we're just going back to our, the algebra 1, the good old days, just using your inverse operations. So there's an important thing to remember though, that my numerator is all being divided by 2. So if I want to undo dividing by 2, what I can simply do is just multiply by 2 on both sides. Now, technically when you multiply by 2, that's going to be a 2 over 1. So therefore that's going to just divide out to a 1, which is just going to leave me with the numerator. But then remember, you have to, whatever you do on the right-hand side, you have to do on the left-hand side. So therefore 2 times -1 is going to give me a -2 equals a -4 plus an x2. Now to get rid of my x2, I'm simply just going to add a 4 to both sides. And therefore I'll be left with a 2 equals a x2. And if you want to write that nice and easy, you can go ahead and just switch them around. So now we know x2 is equal to 2. Now again, let's just kind of verify. I randomly estimated this, right? And I said the value was going to be 2. Now let's go and look at where 2 is, right? If I'm doing my scale by 2, you can see here,
hey, not too bad, Mr. McLogan, right? Hey, not too bad.
I just randomly kind of wrote that in there where I didn't randomly, estimated where that should be. And yeah, I was pretty close, right? So now let's go ahead and figure out what about the y. So I'm going to do the exact same thing. I'm going to replace a ym with a -2 and a y1 with a 5. Now, another way you can actually think about this, if the multiplying by 2 is kind of confusing for you, another way you could also do this is just go ahead and rewrite this. Dividing by 2 is the same thing as multiplying by 1/2. So sometimes students will get confused with the inverse operations. And I say, fine, if you rewrite it like this, hopefully you can now see that, oh yeah, you could distribute the 1/2 if you wanted to, but why would you want to do that? Let's get rid of multiplying by 1/2. And the way we're going to get rid of multiplying by 1/2 is just to multiply by 2 on both sides, just like we did over here. Same idea. So therefore we have a -4 equals, now those are going to multiply to 1, right? 1 times this is just going to be a 5 plus a y2, right? And then subtract a 5 on both sides. And -4 minus -5 is going to be a -9 equals a y2. So therefore you could say y2 equals a -9. Now let's go and check to see how close I was over there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Not too bad, right? You can see, hey, here is my point right there. So when you're given the midpoint and the endpoint, just make sure you're using these midpoint formulas to help you go ahead and find the other endpoint. And basically make sure you're careful with your inverse operations as well as to label everything. If you need more examples of how to find the midpoint and endpoint, check down my examples down below. Or if you're ready for the next video using the midpoint, go ahead and check out my next video I have for you here. Cheers.